Today we will start about the biopotential electrodes. Biopotential electrodes have metal and electrolyte interface. First we will consider as a metal and second one is a electrolyte interface. Okay. So metal have the charge is a positive negative charge, and for example electrolyte water based electrolyte have a positive charge. Now this is your metal electrode. Now this is your water based electrolyte. Now, electrode potential is developed across the interface, which is proportional to exchange of ions between the metal and electrolytes of the body. When we want to put a moment into a metal, the liquid ions in the liquid will come and absorb. If you want to keep any movement, now this positive ion it will be attracted with a negative, and negative ions it will be attracted with the positive. Then it will form a one layer of the charge. If for example I have to be written here, so one layer of the charge. Now it is a one layer of the charge. This is your one layer of the charge. If the potential measured from the human being physiology, so two electrodes are needed and double layer is needed. This reason, this single layer electrode is not measured by the accuracy of the output from the human being physiology. That's why. So we'll how to interface this single layer electrode into a human being physiology. Next we will move into this is your equivalent circuit of the biopotential electrode interface, and a double layer of the charge at the interface serve as a capacitor. The equivalent circuit of the biopotential electrode in contact with the body is comprised of a voltage in series with the resistance capacitance network. A DC voltage on account of the difference in the electrode potential is known as electrode offset voltage. This is an equivalent circuit of the biopotential electrode interface. Now, and here C end, here we need to consider here the C end are A. It will be acts as electrode and electrolyte interface. So that means like a impedance of electrode and electrolyte interface. Now whereas here the RB it will be acts as the resistance of the solution, whereas capital E is the battery voltage or the half cell voltage. And final interface with this last one is a body final. This is the equivalent circuit of the biopotential electrode and electrolyte interface. Now this is your single layer electrode. Sometimes the single layer electrode it cannot give a high accuracy output signal, means it will gives a noise on the bioelectric signal. So we will avoid this type of noise by using electrolyte coating with a piece of pure silver with a silver chloride. Then we want to move into the double layer electrode. Now we want to move into the double layer electrode. Now this is your double layer electrode, the equivalent circuit of the double layer electrode. Now this is your one of the single layer. Now up to this one is a single layer, one layer of the electrode and other layer of the electrode. Now it is a double layer electrode. The potential across the single layer first layer electrode is a EA. The potential across this second electrode is a EP, and RB is the resistance of the solution of the first electrode, and resistance of the solution of the second electrode is a RD. And whereas the impedance of electrode and electrolyte of the first electrode is a RA and CA. The impedance of a electrode and electrolyte of the second electrode is Rc and Cb. Now these two electrodes are interfacing by using the resistance is called RBF, that is your body fluids. The voltage drop across measured by using the first electrode and second electrode, V is equal to EA minus EB. Now this entire is a double layer equivalent circuit diagram, and this we want to see the general one is a polarization effect and second one is a non-polarization effect. Now in this polarization effect means without applying any electronic voltage into a particular electrode, without applying any external force, without applying any external pressure, at that time there is no net EMF is generated across the output of the electrode. This effect is called as a polarization effect. Non-polarization effect means sometimes if you are applying the some external force, then also it will give some output signal, electrical output signal. Sometimes we are not applying the external input voltage or external force or external pressure, at that time also it will give some electrical output signal, is known as a non-polarization effect. And generally this is your double layer electrode. Next we will move into the cross section diagram of the skin interface, how these first electrode, no, electrode 1 and electrode 2, positive electrode and negative electrode, electrode 2, how to interface with the human being body. Now we want to see the generally human being skin consisting of a three layers. One is a epidermis, second one is a dermis, and third one is a substance layer. It will gives a body to protect it from the environment. Skin also serves as a appropriate interface. The outermost layer is known as epidermis. This is your outermost layer. Plays a dominant role in the electrode skin interface. Layers, thus epidermis is a constantly changing layer of the skin. The outer surface consisting of a dead material having a different characteristics from the live tissue. Generally, the layer down below the epidermis layer contains a vascular and nervous components of the skin. In addition, have a sweat glands. Now, this is your sweat glands part, and sweat ducts also there in this location. Sweat ducts and hair follicles. Sweat glands do not follow any unique electrical characteristics on the skin. Now the electronic concentration between the electrode and the skin through the electrolyte gel, how to interface. Now this is your human being physiology, and previous one is a double layer electrode. Now to how to interface electrode, double layer electrodes into this human being skin interface. That is your a body surface electrode placed against the skin. Electrical equivalent circuit elements are approximately the same level at which physical process exists. Now here the basic your in that first one is a one is for the electrode. Now double layer electrode, that is your first one is a electrode, and this is your human being skin. In between the electrode, in between the electrode and the human being skin, we are applying the gel here. So without applying the gel in between the electrode and human being skin, it cannot give the high accuracy output signal. This reason we are applying the electrolyte gel here. It will reduce the error and noise signals interfacing between the human being skin and the electrode. The electrode impedance, now this basic electrode impedance of electrode and electrolyte, that is your CD and RD, and the resistance of your solution, that is your gel, is a RS. This is one layer of the electrode, not your single layer of the electrode. And go for the second one is a and gel one is a gel and second one is a skin interface. First one is a electrode and gel interface, and second one is a gel and skin interface. This is your second interface. The half cell potential of the gel and skin interface is a ESC, and the resistance and capacitance, so that is your impedance of the electrode and electrolyte interface of a skin is CE and RE, and the resistance of your internal surface of the body is RU. So remaining other resistance and capacitance and upsell potential, so that is your sweet glands and sweet ducts. Now here EP and CP and RP mentioned here. In this, RC is a epidermal layer impedance, that is your, in general cases we will consider, if you are considering the general cases, for 1 centimeter square, for 1 centimeter square, the skin impedance reduces from 200 kilo ohms at 1 Hz to 200 ohms at 1 megahertz. The fluids scattered by the sweat glands and contains Na plus and K plus and Cl minus ions, and concentration different from those in exact cellular fluids. There is a potential difference lumen of the sweat duct and dermis and substance layer. There are also parallel, that is your RP and CP combination in a series with this potential that represents the wall of the sweat glands and ducts. If a part of electrodes is in the electrolyte and one moves, whole other remains stationary. The potential difference appears between the two electrodes during this movement. This potential is called the measurement of the biopotential. This, it will be effect on the non-polarization effect, and sometimes it will be effect on the polarization effect. Polarization effect is most not possible, but non-polarization effect, we are applying some external pressure, then the electrode will give us the potential difference between the double layer electrode. The next we will move into the types of the electrodes. What are the types of the electrodes? So microelectrodes and body surface electrodes and needle electrodes. Now how to interface these different types of the electrodes into the human being, so body. Now we want to see in the first one is a microelectrode with a metal film on the glass. Now this is your thin metal film on the glass, and centrally this is your thin metal film on the glass. These tips means like this is your thin metal film have a tip small enough to penetrate a single cell, that is single RBC or any blood vessel. As such, reading from within the single cell can be obtained. Microelectrodes, of course, in general, two types are there in the metal microelectrode and micropipette microelectrode. So metal electrodes are constructed by a electrolytic etching the tip of the fine tungsten or the like or a stainless steel so wire to desired different size. So this is one type of a process, and subsequently how the wire is coated almost to the tip within the insulating material, so like a drawn glass insulating material and resin insulation for the protection for the external environmental. Finally, gold plated pin connector here, the interfacing into the other computers, like a gold plated pin connector here. This is your pin is a connecting and disconnecting, and here also interfacing the object of this gold plate pin connector into the remaining metal thin film of your microelectrode part. So now remaining this microelectrode part, a thin film is the general process here. In this thin film, this precious metal is bonded to the outside of the drawn glass microelectrode. Such microelectrodes are very reliable, having very good performance. The impedance of the microelectrodes in the mega ohms, and naturally, this demands amplifiers of a very high impedance to avoid loading the circuit. That's why almost prepared in the hospital section in the microelectrodes for the measurement of the heart potential as well as a human being brain potential. Most of the cases will prefer the microelectrodes only. Okay, and these microelectrodes how to interface, for example, into the human being brain or heart. This is your a thin metal. If you are interfacing into this thin metal into the human being, so body, now this is your thin metal, this can be interface, then it will give us a potential difference between a positive ion and negative ions, which can be measured by using this gold plated pin connector to interface with the computer. So we can analyze the brain analysis of the human being body parts. Now we will move into the second one, that is body surface electrode. Now, so body surface electrode in that first example is a floating electrode. So this biopotentials from the surface of the body can be measured generally in this case, and available different sizes in the form. Larger electrodes are generally used in the electrocardiography, and second one measurement, sometimes it measurement is not possible. The smaller electrodes are suitable in the electroencephalograph and electromyogram measurements. The floating electrode is available. So now this is one of the example of the floating electrode. This electrode practically eliminates the movement of the artifacts by avoiding the any direct contact of the metal. So within the skin, the electrolyte paste or jelly serves as a conductive path between the metal and the skin. So where is the human being body part is there in generally, so I have to be brief explain here this floating electrode. Now in this floating electrode, to interface into the human being brain, for example, if I need to interface into the human being brain, so now this floating electrode, if for example human being brain, it will be located here. Now human being, so brain here. Now to interface, how to interface, now top above this one is a, now above this part is your electrode part, below this is your human being brain interface, remaining this is your human being eyes and remaining nose, this is your interfacing. Okay, floating electrode, it is suitable for the measurement of the human being brain potential as well as the heart potentials. Now the remaining parts in this brain electrode, that is your silver chloride disc is there, metal plate here, silver chloride, one part of the metal electrolyte here. This is your silver chloride disc, and second one is a lead wire connector and skin interface, and space for the electrolyte jelly for to get the proper reading from the human being physiology, and this plastic and rubber supporting. Now we will have the plastic as well as a rubber supporting here, for there is no means like you can once we have to be keep on this body surface electrode into the human being brain scalp, so we can hold them onto the human being brain. Otherwise sometimes it will be not give you a proper reading this region, so we will prefer into the plastic or rubber support spacer here. So next one is for the needle electrode, how to penetrate the needle electrode into the so human being physiology. So that is your third one is a needle electrode for the measurement of electroencephalography. So that is your brain potential. This is simply inserting through the small section of this skin just beneath the surface and parallel to it. Now this is your lead one. Top one is a positive electrode and below one is a negative electrode. So this is your needle. This needle can be inserted into the human being, so brain. Now for example, this needle can be inserted into the human being brain. If I have to be drawn, this needle can be inserted into the human being brain. So here the human being, so brain, so this is your human being, so brain. So this needle can be inserted into this needle, this small needle, this can be inserted into the human being brain. So is there any thinking from the human being brain, or you can drowsiness at the times you are inhale and exhale and drinking some drowsiness liquids and poisoned fluids. So this can be measured by using the needle electrode also. For electromyogram application also, this needle electrode are basically of the fine insulated wire is placed on their tips and contact with the nerve muscle or the tissue from the whose measurement is to be made in practically. This needle electrode can be inserted into the human being uh, muscle potential also. Now the direct contact with the tissue or the intercellular fluids, needle electrodes have lower impedance than the surface electrode of comparable interface area. As compared to the area wise, now this low impedance than the surface electrode. Needle electrode is very low impedance compared to the surface electrode. Now these are the three types of the electrodes. One is a body surface electrode, a needle electrode, and microelectrode.